Hello, November 23rd. Alright, yesterday was a little bit miss. So I spent a bit more time doing this. I can see I did. No, that's not yesterday. Oh, my bad. Let me refresh. There we go. This was yesterday. We're having an easy one today. And I was not happy. The initial submission, you can see initial one is like really long, and actually I didn't even do my original idea. This is the take one and then or not take one kind of DP idea, but the initial implementation was very bad, right? 2000 millisecond, and then I updated it, which I think is a good update. Basically I added all the ones that's already divisible by 3, so I don't have to consider them again. And then I do the same thing and improve to like shave it in half, right? But then I was like, yeah, that's probably the recursion is killing us in the time. So I finally wrote another version, which is a bottom up. The same exact same thing, but since it's bottom up, you don't have all the recursion stuff. And look at the time we have achieved. This is marvelous. Right? It's a marvelous difference. Now I remember when we were doing Python, the top down and bottom up solutions don't. There are differences in performance, but not that dramatic. Like this is ridiculously dramatic, right? You're talking about like what? 100 times, right? more than 100 times, 200 times, right? More than 200 times efficient. So that's just something to keep in mind, that C++ bottom up, and I think I've encountered this multiple times, that it's definitely a better solution. All right, we have an easy one today, which made me think maybe we should do one of the ones in the past. The one that we already have an idea how to do, but I don't remember which one. I think this is the one. Okay, we're gonna try this one. Let's just deal with today first, and then we try the other one. It was early. I have some Ghana. Let's do it. Oh, by the way, I went to the library today and I got 3 books. I got The Martian. I mean, it's a sale, right? I got it for 50 cents. I had The Martian. I read it first time by audiobook. I remember it was in 2019-ish. Yeah, 2019, 18 or 19, 2019. I was driving to an internship. I was living in Florida back then, and the internship is in Georgia, in Atlanta. So I drove there. I remembered that on the way there, I first tried to listen. I downloaded some audiobook, right, to listen while during the drive. It's I don't know, 4 to 5 hour drive, so it's not too bad. So I had some audiobook downloaded, and the first audiobook I listened to was Stephen Hawking. I think it's A Brief History of Time, and dude, it put me to sleep. It was so bad I have to pull over and just took a nap. It was just that bad, and I decided, no, I'm not gonna do that. And then I put on, because the idea was I'll listen to Stephen Hawking's book on the way there, and I'll listen to The Martian on the way back. But it didn't work, so I ditched Stephen Hawking's book and I went straight to The Martian. So I listened to The Martian for the rest of the trip, no sleepy at all, but I also was not able to finish it. So after I got to the destination, I started my internship, and I kind of downloaded the book. I think it's illegal. I pirated it, and I was able to finish the book while I was doing an internship. And on the way back, I remembered that I listened to the book again because it was just so good. I did it again. So I think I got the book 2 times, right? 2 times. And then, fast forward a few years, I also read his second blockbuster, right, bestseller, the Project Hail Mary. Amazing. I think I finished it in like a day and a half, maybe 2 days. Oh, it was an amazing book. Some people don't like the way he writes. They say it's the same character over and over again. I don't give a. I mean, you're not reading his story to learn about characters, and you do it by solving the problem along with him, and then trying to see how he solves those engineering problems. And it was amazing. But I got the second book on Kindle. Never really got a paper version. So actually I don't own any of his book in paper version. So today is the first time I actually had a paperback version of his book. I feel very good. And also, library sale is always amazing. 50 cents. The book was selling for, I think, $20, and I got it for 50 cents. Anyway, so that's just something I want to share. Let's do this. Binary prefix divisible by 5. You're given a binary number. We define xi as the number whose binary representation is the subarray, the prefix. From the most significant to least, okay. For example, that x0 is 1, x1 is 2, and x2 is 5. Return an array of Boolean's answer, where answer I is true if xi is divisible by 5. So we will just go ahead and do this. That's an easy problem. No issue here. I just need to document this thing. Okay, this is 1018. Let's see. We need a answer. We call it res for int n of nums. Okay, so we need int val. That's I think it should be 0 because I need a left shift, right? So every time what I do is I'll say val equals to val left shift 1, okay, and we'll or n, and we'll say res dot pushback val mod 5, whether it's divisible, so it shall be equal to 0, and now we'll return res. Okay, let's give this a run. Oh, my bad. This is Boolean. Yeah, it's a compilation error. It's supposed to be Boolean. All right, looks good to go. No, it is not. I think we might have how long is this? Darn, 10 to the 5th. Oh, okay, I really cannot do it this way. I think it's overflowed. So divisible by 5, so it has to end as a 0 or a 5. How do I know if it ends as a 5? By looking at, or because this is multiply, right? This is multiply by 2 and then plus this. So technically what we can do is to keep the remainder, right? So we have a value and I will mod 5, so I know the remainder, and then I'll do it again and I have the remainder. So the remainder will remain the same, which means this is not going to be correct. So do we record the Yes, we record the remainder. Wait, hold on. We will record the remainder? Yes, we record the remainder. So we'll do something like this, mod 5. And we'll do this equal to, oh man, this is actually, I'm not sure. This we're entering a territory I did not prepare, but we can try to see if it works. Well, I think it should, because we can simply just do the remainder, but I'm not sure about this part. Well, I guess you're right, because multiplication and add, or you can like make this more explicit, right? You can just say r times 2 plus n. You can just keep doing the modulo, and I guess it's okay. Yep, it is okay. Yeah, 10 to the 5th, that's not possible. If you want to do it some other way, you have to modulo the whole time. Okay, so this one is done. Let's take a look at this one. I need to remind myself what this one is about. Maximum frequency of an element after performing operations. You're given an integer array nums and 2 integers k and number of operations. You must perform an operation this times on nums, where in each operation you select an index I that was not selected in any previous operations. Add an integer in this range. Add an integer in the range to this. Return the maximum possible frequency of any elements in nums after performing the operation. I need to read my previous thought, because I remember I have an idea of how to do this. I just never attempted. So I have left bound and a right bound. And the index for the largest index that is not bigger than p, call it m, and then we can calculate index. Then we move the entire window. So the entire window. Okay, I kind of hold on. So what we want to do is, given this array of numbers, right? Given this array of numbers, I want to perform number of operations on them, right? We don't know how many operations there are, but the number of operations on them. And this is to add an integer in this range to this value. So we can increase, we can decrease, which means if I kind of remember what the easier version of this problem is. There's an easier version, which is the first version of this problem, which the length is not that big. What we do is we just go through every single possible value. So we sort, right? Do we sort it? An index that was not selected, add an integer to it. Yeah, we sort. We sort nums, and then we go through, because at the end of the day, there will be a conversion number. And what we just want to see, given a conversion number, we just define a conversion number. We want to see if it's possible that everybody can converge to that given the number of operations, right? So I have a conversion number, and I will just go through the whole thing, and then if a number can be, which means if it's the distance between the nums I and the convergent number is within minus k to k, then we call it, yes, it's possible. And if it's outside, then it's not possible. And we will, get to a number, maximum possible frequency of that, and then what? The max possible frequency. Yeah, so I try a number, then I go through the whole thing, and I have a frequency. Yeah, I think that's it, just like O1 squared, right? Actually, I need to double check, because this is the easier version. That's O1 log n, all possible, and then check how many numbers can converge there. Yes, we check. Oh, I think the converging part is binary search. Yes, the converging part, because we have the number that we will converge to, and then that number basically minus k and a plus k, right? So we have every single one. Yeah, and then we have a left bound, we have a upper bound, lower bound, and upper bound, which is this. And now we do this, and everybody inside can be can converge. And also we have these that's already, so we don't have to converge, it's already the same. And then the eligible will be the must converge and the smaller of the two, and the answer will be this plus eligible, and then you get a max. Yes, okay, so that's perfectly fine, but we can do it because this is 10 to the 5th, all right? But in this case, this is 10 to the 9th, so we cannot go through every single one of them. But what we can do is to go through every number, okay? Every number. We're going to do exactly the same thing, but we don't go through every single element from the smallest to the largest. We just go through every element in nums. We say, okay, we're going to converge in nums 1 or nums 2, right? We're going to converge to that. So if that's the case, what are we looking at? So it's the same algorithm as before, so we can get one. So that's one scenario. And the second scenario is we do not converge on any of the element. We'll converge on something that's in between, right? So this is where we will use a sliding window. Okay, we'll use a sliding window, something very similar to what it's doing here. So sliding window means we have the target, right? We have the target. Actually, it's not one by one. It's we have the maximum range, right? Maximum range, which means it's like this. The left bound is going to be this. The convergent number is going to be this. The right bound is going to be this. This is what we're starting with, right? This is what we're starting with. And once we're done with that, right? So this is the maximum we can get. And we need to figure out how many is like only the elements in between this can be converted, right? So this is the maximum possible, and then we can get the distance. because we're guaranteed p is not part of the original number, so everybody is within it has to convert, right? So we've done that, and then we're gonna move forward, right? When we move forward, we'll move this entire window forward, and as we move forward, on the left hand side we'll just skip, right? Because the ones in between is not going to make any difference, so we'll just jump to the next one, right? We jump to the next one and we do the same thing, and then we jump to the next one, we do the same thing until we hit the end. I think this might work, and I don't remember when was first done. 21st, so maybe this is from 720. No, I think this is from 22nd. This is likely from 22nd. So let's try 22nd. It's no October. Wow, that's like, oh, what the hell? Huh? Oh shoot. My bad. So what we need to do is, gosh, and this has to be this. Yes, this is the one. Okie dokie. Let's go solution number 3. Alright, let's try this again. We will divide the problem into 2 parts. We will divide the solution into 2 parts. First, the convergent number is an element in nums. We can use binary search to handle this scenario. Second, the convergent number is not an element in nums. We can use sliding window. Okay, sliding window to handle this. Sliding window and greedy to handle this. Basically, we will set the left bound of the -k to k range, right, to some nums I, right, and count how many elements are within this range, because those are the ones that we can do. So I look forward to this runtime. All right, so first part one. Part one, the convergent number is an element in nums. So what we need is an unordered map. So I need a count. Okay, counter for int n of nums. We just do counter and plus plus. All right, so we have the counter. We need to sort nums.begin, nums.end. Perfect. And then we're just going to go through nums one by one and then say if that's the case, then we go lower bound, upper bound, right? And then we'll find out how many is in between, minus this. Okay, so we do for int n in nums again. right? Nums, and lower bound is maximum 0 n minus k, right? N minus k. This is a lower bound. Let's just call it low and high. I think it's easier. High is gonna be minimum. Actually, there's no minimum. Actually, it's even not this. I think it's safe just to do this because we're doing binary search. So low is this, high is this, right? Because anybody in between this range can get to n. Okay. So we have that. All we need to do is binary search. So like a low iterator will be. Do we want lower bound or do we want upper bound? I think we want lower bound. Right, I think we want lower bound on this. Lower bound. Actually, I forgot what lower bound, upper bound is. Again, lower bound. What's lower bound? Lower bound. First element that is not less than. Yes. So lower bound. What's the signature? Lower bound. Lower bound. Begin and the value. So nums dot begin. Nums dot end. Value is going to be low. Okay, that's lower bound. So this will hold the iterator pointer to the first one that's larger equal to low. This is what we want. And then we have to hide this, right? This is going to be the upper bound. Again, the same thing, nums.end and high. So this is the one that's larger than, right? So the difference is going to be the number in between, right? 0, 1, 2. 3, so that's in 3, 1. Yeah. So we also need a res. Let's put res here. All right. So here, res will equal to maximum res. So this is gonna be std distance, low it, high it. I'm pretty sure this is the distance between the two, which is the number between the two. You know what? Let me just double check on distance. So distance begin and a third point into this. So 0, 1, 2. So give you 2. Wait, hold a second. Hold a second. So this is just iterator minus the other iterator, right? Plus 1 plus 2. So this is this iterator and this distance is the distance between the two, which is 2. So 0, 1, 2. 2 minus this, right? Which means in our case, it is high minus low. Because high is the one we don't want, like 0, 1, 2. 2 is one we don't want. We want the ones in between. Yes. So this is the total, right? Minus counter n. This is the one we don't need. But we also need to take the smaller of num operations because we cannot take more than that. So, yep. I think that's pretty much it. No match for call. I'm pretty sure I need to cast, or is that safe cast? I forgot how to. Cast to int. I forgot how to do that. Static cast, my bad. So I think I need to do static cast int of this. Okay, so that's part 1. And then part 2, the conversion number is not an element in nums. So for this, what I need to do is for int, same thing, nums, right? And then we say low is equal to n. Int conversion is n plus k. High is n plus 2 times k, right? And we say if counter.contains converge will continue because we already handled it, right? We already handled it here. Otherwise, we basically have low and a high, and then we do it exactly the same thing, right? We do it exactly the same thing, and maybe we can copy this. Right, low will do this, high will do this, yeah, and then this is the mean operation distance. We just don't need to minus because it's just not necessary, right? The distance is the total number that we need to do, and then once we're done, move on to the next one. And now we'll return res. All right, let's give this one a shot. See how this one goes. I have no clue, but let's try it. Okay. We were wrong in the first one. I do not understand. Conversion number is 4. Oh, wait, hold a second. This is not right. Hold on. So num operation, operation needed is going to be this. Okay, this is the number of operation needed, and eligible is the minimum of num operations and operation needed. Okay, we will only do this amount of eligible, and the final answer is going to be, this is going to be what? So we have this amount that's eligible. So eligible plus counter n. Okay, this is what we can do. And here is so the minimum number of operations. So like everyone has to change, right? So we just get the minimum number of operations, and this, I feel this probably is right. So give this one a run. Oh yes, this looks promising. That's all right. Where did we go wrong? Plus, the k is huge. Okay, so Ugh. Ugh. We probably should long every single one, right? But n and k, neither of them are long, so I shall do like long. Can I do long here? Do like a long here? Not 100% sure, but we'll give it a shot. I think it's good. Actually, I'm not sure if the last one was even included, so I'll just run the last one by itself. Looks good. Oh yeah. Oh yeah. This worked. Oh, this freaking worked. Oh my god. Look at the bloodbath. Hey, I'm even achieving better performance than the official solution. I don't even know what this one is. I just copy and pasted. I copy and pasted. I did not understand. But look at this one. Holy crap. It's simpler. It's straightforward. It's just, good in almost all ways, except from the little error we got earlier. Dude, this is so good. This is so good. I could have, like if contains, I just do this logic. But I guess it's okay, it's not too big a deal. But wow, this is amazing. That's why I don't give up on all those problems. I have faith, right, in my capability. It's just, sometimes I need a different mindset. I need more time. I need more leisure in order to do things like this. Oh, this is gonna feel so good. All right, that's it. This one is done. Well, we still have all the other ones lingering around, but well, I know I have an idea how to do this because this is an old problem. I do not know how to do this. I think I just copy and paste on this one. I do not know. Maybe I do. Maybe I do. I don't. I have no idea. Yeah, this requires more work. But hey, this one's good. And we also have this one. Not sure about that, but this one is done. No. Is this one? Yes. This one is done. What? I already upvoted. What happened? There we go. Okay.